after today's session. Welcome everyone. So today's sessions, we will focus on emerging technologies in the mining sector. And these are technologies that will help improve energy efficiency and or decarbonize the mining sector. So if you are not in the mining sector or you just decide that this is not what you want to listen to today, we'll also have two subsequent sessions in 2025, one for the steel sector and one for the manufacturing sector, where we'll discuss different technologies that might be relevant to these sectors as well. So in order to be aware of when these sessions are planned, you can either sign up for a newsletter or check the calendar, and I'll put these links in the chats for you. So one caveat for this session today, it was intended to be a 1-hour session. We booked an hour and a half, so we'll have lots of time for questions, but we might also finish a little bit early. If we can go to the next slide. So if you want to participate in the discussion, you can use the chat. So you have a little note here on how to use the chat. I think everybody is fairly familiar with that. If you have questions that you want us to get to throughout the presentation, you can either put them in the chat or in the Q&A tab. And if you want to ask a question throughout, feel free. Our presenters will make some time to answer as questions come up. So you can raise your hand and we'll read out the questions that are in the chat as well. Next slide. So now I will let our presenters for today introduce themselves and get started with the presentation.
Thank you so much, Maëlys, and happy to be here and to speak about emerging technologies in mining. So my name is Emily Thorne-Corte, and I have a few letters after my name. I guess the most relevant here is I'm a professional engineer, certified energy manager, and certified measurement and verification professional. I run a industrial decarbonization and energy efficiency consulting firm called Thorne Associates, based in Toronto, and have worked for 20 years in industrial decarbonization and energy management, and have significant experience in the mining sector. I'll turn it over to my colleague, Bob.
Good morning, everyone. Great to join you this morning. I've been working in mostly heavy industry most of my career for, I say 30 years, it's probably more like 35 now. But the last 20 plus years, 22, 23 years, I've specialized in energy management and renewable energy, various energy technologies for wide range industries. Done a lot of work in the last 10 years or so with things like ISO 50001 and a lot of work with the Save on Energy program, and have been in and out of the mining sector over many, many years, even way back into university. So it's a field of particular interest for me, and love to see it thriving, and any especially in the energy side of it. And hope we can answer some questions or get you looking at some new technologies today.
Thank you so much, Bob. So yeah, Bob will feel free to jump in at different points in the time to add any additional sort of comments and help answer questions. I do want to mention that there are some other colleagues of mine from Thorne Associates, some just listening, but in particular, Michael Powell is here, and he's not an official presenter, but may help in answering any questions you have as well. Okay, so in terms of objectives and agenda for today's session, we're going to be introducing 6 different emerging technologies in the mining sector that support energy efficiency and decarbonization. One thing to note is that we have defined a technology as emerging if it is not widely adopted in Ontario. So it could be, commercially available and widely adopted elsewhere in the world, but if it's not widely adopted in Ontario, then we believe that there's an opportunity for this technology, and therefore it's part of our kind of scope. And the other thing to note is when we say mining sector, this includes both the actual ore extraction from the ground, so sort of traditional mining, and the mineral processing aspects. We are not looking at technologies related to smelting and refining in today's session. So the six emerging technologies that we're going to be discussing are battery electric mined vehicles, hybrid electric haul trucks, both diesel batteries or traditional hybrid, and we've grouped in diesel trolley assist as sort of a type of hybrid, continuous miners, ventilation on demand, in-pit crushing and conveyance, and a couple alternative milling technologies. So before we dive in, and for any of those who just joined a few minutes late, as Maëlys mentioned, this is emerging technology in the mining info session, but there are going to be two others. So there's going to be emerging tech for steel info session at the end of January, and then there's going to also be a general manufacturing emerging tech. And when we say emerging tech, that's for energy efficiency and decarbonization, sometime in Q1 2025. So the exact date is still to be determined. So just before we get to the technologies, I'm just going to go over in a couple slides some key statistics, kind of set the stage about Ontario's mining sector. Mining is very important sector for Canada's economic growth. Critical minerals are essential for the energy transition, as I'm sure most of you know, and it is therefore necessary that we find ways to mine as efficiently and with low carbon emissions as possible. So Ontario is the second largest mining sort of province in the country after Quebec, producing over $13.5 billion worth in minerals in 2022 and employing 31,000 direct workers and 47,000 indirect workers. You can see there's a kind of like 1.5 indirect workers for every direct worker. So it's much larger than you might see just from sort of direct employment. There are 36 active mining operations in Ontario. You can see the majority of them are in the gold sector, another significant number in base metal, and then 1 in iron, platinum, and 8 in industrial mineral mines. And 10 of these mines do produce critical minerals that you can see listed there. So miners often ask us, how do we have greenhouse gas reduction targets and still grow? And our answer is to decouple the growth from emissions. So you do this by decarbonizing your operations and investing in an energy efficiency and ensuring any future expansions and mergers and acquisitions are doing this as well. And just continuing along with some key statistics. So in 2021, the Ontario mining sector consumed 41 petajoules of energy. I had to look that up myself because I go up to gigajoules and terajoules, but I think that's it. So petajoules is 1,000,000 billion joules, or 10 to the 15th joules, so AKA lots of energy. And about 47% of the energy is electricity use, with the balance being mostly diesel and then smaller amounts of natural gas and propane. And in terms of scope 1 emissions, so your direct emissions, that's about 1.5 megatons for the Ontario mining sector. As I mentioned, traditional diesel mobile fleets account for the majority of the scope 1 emissions. And then natural gas and propane heating are the number 2 from a fossil fuel perspective, and they're typically the mine air heating and then for either process heating or building heating. So scope 2 emissions generally are offsite electricity generation. There's not a lot of, technically scope 2 does include other purchased energy. It can be like purchased steam, which for example can be used in steel or other manufacturing sectors. It's not often used in mining. So scope 2 is usually just offsite electricity generation, and electricity is used mainly to power underground ventilation or in the mill in crushing and grinding. Hoisting is, of course, underground, or other conveying and pumping. And I wanted to add that the mining sector is also actively implementing renewable energy, maybe less in Ontario than globally, because Ontario's grid is relatively clean. It's about 87% zero emissions in 2023. Unfortunately, Ontario has gone in the wrong direction from my perspective as an environmentalist, in the sense of we used to be at about 95% emissions free, and that has decreased over the last few years in the province due to the policies in place. And just so FYI, in your projections, it is important to look at the Scope 2 emission projections for the province, because as some of the nuclear facilities undergo refurbishment, then natural gas generation is looking to take some of that place. So we will see some further sort of increase in emissions before hopefully those emissions going down. So for those who did miss it, we did do a training similar to this one on power purchase agreements and Ontario's clean energy credits to reduce Scope 2 emissions, and we can provide access to those if you'd like. At the end of this slide deck, there is a link to the Save on Energy's training and support, and you can find a variety of different trainings that we at Thorne Associates and in conjunction with CIET and other CIET expert providers have conducted in the past. And lastly here, mining sector electricity use is expected to increase with the adoption of electric vehicles. So unlike some sectors where electricity is decreasing, it is having a significant projected increase, and also with the adoption of electric heating technologies, industrial heat pumps, and others. So now we're going to go through each of the 6 technologies and start with an overall description of the technology, followed by the advantages, some considerations, and adoption. And before I dive into the first one, just Maëlys, do we have any questions or comments at this stage?
No questions yet.
Okay, perfect. So just as a reminder, feel free at any point in time to put questions in the chat or the Q&A as Maëlys mentioned. Okay, so our first technology is battery electric mine vehicles. So Ontario is actually a world leader in adoption of these vehicles, and I hope similar to myself that has an electric car, we were an early adopter as a family. So we had a Toyota Prius back in, oh gosh, I think it was 2008, and then switched that. There was no plug-in available, and then switched that out for a fully electric Chevrolet Bolt, and we ordered that in 2018. So, electric cars have many similarities, if any of you do have them, to battery electric mine vehicles. So they have no internal combustion engine, and they're powered by an electric drivetrain using rechargeable batteries that are mainly lithium ion currently. So they do typically, in terms of the BEVs, have similar or better mobility versus conventional diesel engine powered equipment, and better traction at low speeds. And I think, for the purpose of this audience, the zero local emissions is really important. Again, I already kind of talked about the Ontario electricity grid emissions, but nonetheless, even with it going to be a bit dirtier in the future, it's still, from a life cycle basis, absolutely worth it to purchase and use battery electric vehicles. You are like, from an emissions perspective, you have to do the cost to see if that makes sense for you or not. Right now, battery electric mine vehicles, or BEVs, I'll use that acronym, are being mostly used in underground mining, as the large haul truck sizes needed for the open pit are not yet available. However, they should start to become available in about 3 to 4 years, around 2028, 2029. So just in time before the 2030 goals, if there's no delays. But yeah, you have to check in with the OEMs. They sometimes change their dates, although Caterpillar actually brought theirs forward. They were actually going to be after 2030, and they brought them forward. So we'll see if they can actually meet those deadlines. And then depleted batteries can be charged on the vehicle, like what we do for our cars, or what we do not do for our cars is the batteries can be swapped out for a charged battery in the garage. And that is a pretty quick process. And so that can help, reduce any downtime. And there are also some newer business models where you can rent the BEVs, or you can rent just the batteries, and the OEM takes on the risk of the battery lifetime and maintenance. So we are seeing a number of sort of innovative, newer business models, similar to we saw in the sort of photovoltaic, like solar panel model, business models that are helping to assist purchases in BEVs. And I would say one of actually in my opinion, the biggest benefit to BEVs has nothing to do with energy efficiency or greenhouse gases. It has to do with the health of the workers. And, diesel is a known carcinogen. So I think that, when you're trying to sell purchases of BEVs, like internally, if you're with a mine, or, as a consultant, to to a mining company, suggesting, or utility, et cetera, suggesting the many other benefits that come from BEVs in addition to the energy efficiency and greenhouse gas savings, I think is actually really critical. And we're going to go through on the next slide some of these advantages. So as I mentioned, zero tailpipe emissions, but also, elimination of fuel combustion odors, heat, and airborne particulate matter. And I would like to stress on the heat aspect. So if you're in an underground mine, which again is the largest application currently, and if it's a deep underground mine, then there can be significant heat. And so that reduction of heat, like from diesel equipment, I mean, and also just the rock is hot when you go underground. And so any reduction in heat can actually be hugely beneficial. You might actually have to do cooling underground depending on how deep your mine is, and so that can reduce cooling requirements or just make it more I guess easy for workers to work and potentially have some productivity improvements. So if you think about that, why is there like less heat for BEVs? It's because they're much more efficient, right? So internal combustion engines with diesel or gasoline, they're in the like 30-35% efficient, and the rest is wasted as heat or as noise. And in battery electric vehicles, much more efficient, maybe 85% approximately. I mean, it varies, but let's just take that as an example. And so you have much less heat coming off. Also, the BEVs can reduce the need for underground ventilation, and this can be huge savings. So I would say the number 2 after the health benefit is the cost savings associated with underground ventilation. So especially if you have a greenfield mine, this can save both OPEX and CAPEX. And in the greenfield, you may even be able to reduce the drift sizes. For those who are not in the mining sector, drift are like the underground tunnels. And they're also quieter than diesel engines. This is something I love about my electric car. It's just so quiet, and I like to think of, if I had a dream, my dream would be that it's quiet and we can like talk to each other from across the street and along, Bloor Street, just have nice conversations without so much, noise from all the cars. And I think in the mining environment, it's also can lead to improved productivity from workers being able to more easily communicate, and it can even be a safety improvement. And by the way, I'm emphasizing safety so much for those who are not in the mining sector. Safety is the absolute number 1 before anything. And so if you can show a safety benefit, that's the key to getting anything approved, basically. Improved low-speed traction, longer drivetrain life, lower maintenance requirements, and lower operating costs. I want to put sort of a star here. Yes, that does occur, I would say, for more mature operations that have kind of overcome some of the early adoption issues. So we've seen in the early days that lower maintenance has not been realized, and I'll go through in another slide just some reasons for that. But I think it's clear for those who are more advanced in BEVs and who have been operating them for, the early adopters, like 3, 4, 5 years, they are starting to see those benefits. But maybe if you're just starting, or 5 years ago, that maybe was not yet the case. Improved operational efficiency and reducing or eliminating the need for diesel or propane transportation, storage, dispensing, and conventional fire safety equipment. So yeah, don't forget that, especially if you're greenfield, like that elimination of the entire diesel fuel infrastructure overground, if you're going for a fully BEV fleet, that can be significant in terms of cost savings. There's also no idling for BEVs that can be beneficial as well. So I'll just go to some considerations now, and then I'll take questions at the end and just at the end of the next slide on BEVs if there are any. So purchase price, of course, that I think just again, like electric cars and for BEVs for mining, they are more expensive, 1.5 to 2 times in general compared to their diesel equivalent. However, that range depends on the type of equipment, from personnel carriers to versus haul trucks. Your battery life can be an issue, so that's something that you want to discuss with the OEM, and also your end of life disposal we're not supposed to sort of mention many company names just from an equitable standpoint here, but there is a battery recycle founded by a Toronto entrepreneur who I used to work with. You can contact me. I can give you that company's name if you want to know, but there are some, battery recyclers that are working on these tough problems and making some good headway. Range per charge, is less than diesel or hybrid, and it can be difficult to recharge remotely if the charge runs too low. So that is, of course, that sort of range anxiety, again, similar to the car sort of challenges, electric car, that can be an issue, but again, can be managed. Cold weather limitations, I think that the OEMs are making some improvements here. There are, batteries like a certain nice sort of temperature at its relatively narrow window, but the OEMs are making progress there. Cost of the charging infrastructure, but again, that is offset by that lack of diesel fuel infrastructure if you can get rid of it entirely. Where it's going to cost you the most is if you have a few BEVs and you need that infrastructure and you also have all of the diesel. So if you kind of go all in, there are some more risks, obviously, but some big savings too. And then it can require different and sometimes more complex fire safety equipment. So I just wanted to touch on some of those early growing pains that I mentioned. So what we've seen is that earlier, lack of skilled maintenance staff for BEVs, but there are again training like in Sudbury. I think it's Cambrian College has a BEV training. I believe in BC they also have a training now at one of the colleges for BEV technicians. Lack of inventory of spare parts at OEMs who have made the first of its kind vehicle, and then they don't know which parts are most likely to fail, and they don't have those in stock, and that's caused some significant downtime for some of the early adopters. And battery catching on fire, that has happened, but gasoline cars, they catch on fire too, and it doesn't mean you should not use BEVs. It means you need the proper risk management precautions in place, and miners are experts at risk management. So we've learned to live with the risks of gasoline cars and aviation fueled powered planes. So we can, my opinion is that we can absolutely move forward with battery electric vehicles as we are, but we just need to make it as safe as possible through risk management. And lastly, on the BEVs is just looking at the adoption. So as I mentioned, Ontario is actually an enthusiastic early adopter and a world leader. These vehicles have been in sort of field proven and commercially available for about 5 years now globally, since 2019. Like diesel mining equipment, most of the BEV equipment is manufactured elsewhere in Europe, US, or Japan, but there are some competitive Ontario-based suppliers of equipment, which again, I can give some names if that's of interest. And just noting, as I mentioned, most of the equipment right now is, in terms of like size and range, best suited for underground and temperature, right? It's warmer underground, so you don't have those sort of cold weather limitations as much and proximity to charging stations. But in the future, we do see vehicles coming out, and the OEMs, or original equipment manufacturers, are working on the sizes needed for open pit hauling with greater range and improved cold weather. So I will pause there. Any questions or also comments from Bob or Michael as well?
I don't have any questions in the chat or the Q&A, but I'll let people either raise their hand or write in the chat if they do have some questions.
Okay, great. I'll continue then. Okay, so let's go into the second technology, which is hybrid electric haul trucks. So again, think of your cars, right? So hybrid, our Toyota Prius from 2008 that we've now replaced with our fully electric, but when we had it, it was basically diesel engine, electric drivetrain. And that's kind of the same idea here for the hybrid electric haul trucks. And the idea is to reduce your fuel consumption and emissions. And they also do provide excellent load speed traction. So yeah, the one thing I noticed with my electric car, not so much the hybrid, but the electric car in particular, is the incredible acceleration. And again, I see that as a safety improvement. And in mining, it can be a productivity improvement. Mining does have a lot of speed limit for safety, I guess, restrictions. So sometimes that can be a benefit, but sometimes there are restrictions on the speed. So we're going to look at two different hybrid electric technologies. So sort of a traditional hybrid diesel battery, and then sometimes trolley assist is on its own, but we've kind of lumped it into hybrid. And so we call it the hybrid diesel trolley assist. To be of note, you can use fully electric trucks with trolley assist as well. So the hybrid diesel battery, it has an onboard battery that's charged with regenerative braking and surplus diesel engine power. So external charging is not required. So this is not like a plug-in. This is just no external charging. The range is much better than the battery alone, and it's suitable for long distances of open pit. So I think that the regenerative braking, like we're talking in energy efficiency trading, this is a huge important win, right? I forget the exact percentages, but I think it is in around the 20% range on terms of what you can get back from regenerative braking. So it is very material, very significantly important. And I think this should be done pretty much in any potential application, because to me, it just makes, again, so much sense. And I love that with our electric car. And then the hybrid diesel trolley assist. So for those who are not familiar with this technology, basically think of a streetcar that has those like overhead wires above, and you have like wires that attach above the streetcar to connect it. So it's called a catenary system. That's the technical term for it. But yeah, basically it's like a streetcar. So you have these big diesel haul trucks with this catenary system on top of it, attaching to the overhead wires, and basically power the electric drive motors on the trucks on these common roads and long ramp climbs where you install the trolley infrastructure where fuel consumption is greatest. So that, just to be clear, these trucks go kind of on and off. So you're not going to have the trolley assist system everywhere in the mine, but you'll have it for 1 or a few kilometers in again, the sort of common roads or long ramp climbs. And there's a huge productivity benefit here, because when they're on the trolley assist, they can pull a lot more power and go like a lot faster. I think in some cases up to double the time. Anyway, certainly significantly more. And trolley assist is actually seeing a comeback, because it's actually, a many decades old technology that's getting new life because of the decarbonization goals. And then again, that productivity improvement. As I mentioned, can use 100% electric battery vehicle, but we're certainly not seeing that very often. I think there's only one in the world, to my knowledge, in the mining sector currently. But again, in emerging tech, it is coming. So in terms of advantages, the overall tailpipe emission reduction can be in the range of 40 to 50%. So, not as good as electric, but certainly quite significant. There can be a reduction of engine noise when the diesel engine is not running, and again, improve low-speed traction. And I think the biggest benefit here, other than, again, the health savings from the reduced emissions, but they're not as significant, because usually if you're in an open pit situation, then those emissions gets dispersed, whereas in the underground, the emissions from the diesel is much more significant from a carcinogenic perspective. But other than that sort of potential health benefit, if you're using it underground, which is not as common for trolley assist, is the uphill speed advantages when operating on electric drive. There are less diesel system maintenance because of fewer running hours on the engine, and generally lower operating costs. So that does, depend on local electricity and diesel prices, but generally, and then it's not affected by the cold temperatures or range limitations that we have with the battery only vehicles. So you can have, again, as I mentioned, for open pit, and in some cases, existing diesel equipment can be converted to hybrids. You need to have that electric drivetrain, but otherwise can generally be converted. Some considerations, though, is again price, the capital cost, right? But again, you should always do life cycle costing for any of these technologies, right? Most of them are going to always have a higher capital cost, but if you do the life cycle costing, and don't forget to include the carbon price as well for Ontario and the savings there, then and if you don't know about all those sophisticated, because there's a lot of nuances with the carbon pricing, we'd happy to help you with that. But they're about 1.5 times the cost of conventional diesel, approximately. So again, slightly cheaper than the BEVs compared to their diesel alternative, but less greenhouse gas reduction. And you can have possibly greater and different type of fire risks for the battery vehicles. So that's just a consideration. In terms of costing here, we've given a rough estimate. So, trolley is pretty large capital investment. We've given sort of $8,000 to $10,000 per meter for infrastructure that cannot be relocated. So you do need to make sure the mine plan is very solid and is not going to, change in terms of again, those common roads at least. And it might not be practical, the trolley assist, for sites that experience frequent icing conditions, as ice or frost can accumulate on the wires and bus bars. That being said, we'll see on the next slide, like these, some of these applications are in colder climates like Sweden, which definitely has lots of ice and snow. So it is possible to be used in Northern Ontario, for example.
Well, Emily, just a comment on that. So yeah, that tends to be sort of a fairly local issue. I mean, there are some areas that do have more frequent, like freezing rain events or very heavy frost buildup. They're maybe very high humidity conditions. It's not really all that common. But where it is an issue, it's a pretty serious issue, because then you have to have a whole other set of equipment and crew basically on. It's almost like having de-icing crew for an airport or something, just to manage that. So, but it does tend to be a fairly for most sites, it's not something that would be a common issue. That's
Perfect. Thank you, Bob. Great context there. Appreciate that. And then just, I guess, lastly, as a consideration, we didn't mention on the slide, but you need the space for the trolley assist infrastructure. So it's usually not a problem for open pit. They also have some, I can't remember the vendor, but one of the vendors now has like trolley assist infrastructure on the side instead of overhead. And so that does take up less space, but it can be a showstopper for existing underground operations that wish to install trolley assist, in terms of you do need extra sort of physical space. And so lastly, just in terms of adoption of these hybrid electric haul trucks, in terms of the diesel battery hybrids, smaller vehicles, pickup trucks, vans are commercially common. And then the development and field testing and adoption of the large vehicles like the haul truck is still in the early stages. In our experience, haven't seen many of these hybrid diesel batteries, at the large scale, whereas, BEVs for underground operations in the smaller scale are definitely, again, quite widely, or becoming widely spread slowly but surely in Ontario. And then one example is a 220, so it's one of the large metric ton payload diesel battery hybrid haul trucks tested at an iron mine in China. And then in terms of trolley assist, there's kind of two poster child, I guess, mines. As I mentioned, it's kind of having come back. It's been used, as we've mentioned here, since the 1950s, actually. But in 2018, an open pit copper mine in Sweden, Boliden's 8-Kit copper mine, installed and successfully has operated a trolley assist, and also Copper Mountain Mining's trolley assist in British Columbia became operational in 2022. So I'll pause there and see if there, Maëlys, any questions or comments, or also again, Bob or Michael, if anyone wanted to add anything else.
Maybe I can start, Emily, by reading a question that came up. I think it was right after we switched, so it might be more related to BEVs, but I think we can go through it for both sections. So there was a question, is there any specific company leading the electrification of vehicles in mine? And someone, if I recap what happened in the chat, someone mentioned Goldcorp / now Newmont in terms of the mine, as well as Valley Canada that is using a similar system to the trolley-based. They're using monorail. So I don't know if that's something we want to chat about a little bit. And then Michael also added into the chat as a response in terms of OEMs, Sandvik and Epiroc would be among the leaders for underground vehicle electrification. So I think there's some interest in understanding a little bit more about that.
Sure. Yeah. No, thanks, Miley. So yeah, in terms of, I guess leading can be both on the OEM side and then on the mine adoption side. So on the OEM, as Michael's mentioned, like Sandvik and Epiroc are certainly leaders. I would say from a Canadian example, McLean Mining is also a great. They don't do the haul trucks and stuff, but they do the ancillary equipment. And so I'd say that's from like the OEM side. Caterpillar was very late to the game. They kind of were, well, I'll just speak freely, like a more like, laggard, absolutely kind of the laggard, but they have since done about face and have tried to catch up. And since they have a huge amount of resources and, a huge amount of market share, Caterpillar is very aggressively working to catch up and get those big electric haul trucks for open pit in the market, as I mentioned, sort of 2028, 2029. And then from a mine perspective, in terms of the adoption, yes, sort of Goldcorp now been purchased by Newmont. Who was like Kirkland Lake Gold. Those operations in Ontario were some of the first in the world. And then also, Glencore and Sudbury, they have, they're planning with their Onaping Depth mine to have a fully battery fleet at depth. So that's pretty innovative as well, just in terms of the scale of it, because with Goldcorp, it was more of a, start. They have put in many equipment as well, but it's a smaller scale, I would say. So I think those are some of the leaders. And yeah, Bob, Michael, anything else you want to add?
I guess just on the sort of the performance side too. I've never driven any of these big vehicles, but just what I've seen in general, you've got in terms of control, you've got quite an improvement on low end or startup traction speed, which is another reason historically locomotive engines are typically a diesel driving an electric motor. I mean, that's just to give you that nice torque curve, especially at the low end where you really need the power. And also for, I see this more with, there's been a lot of vehicle publications on it recently, just traction control for like Tesla Cybertruck or things like that, is the electric motor control of the wheels really gives you essentially instant skid control, which is probably something that would apply. I've seen some interesting videos of haul trucks, kind of sliding off roads and things, usually pretty disastrous. I'm sure there's some benefits there. I didn't see anything jump out in my research immediately, but on the skid control side, there's probably some advantages there as well.
Thanks, Bob. Okay, great. Any other comments, Michael, or if not, I'll move on. Or questions, Miley?
No additional questions.
Okay. I'll move on to the continuous miner then. Okay, so this is the third technology. And if you haven't heard of this, basically it's fully electric. So first of all, again, from an emissions perspective, it's very attractive, especially, as we hopefully get to cleaner electricity grid. So yeah, electrically powered vehicles. So these are mobile equipment with rotary cutters. So they're turning that advance with wheels or tracks into the working face. So the basically the mining section that you want to excavate, and it directly dislodges or excavates the rock and the ore. So these are essentially like turning, again, rotary cutters that are cutting and excavating. So it avoids the drilling and the blasting and use of explosives in a typical mining where, again, you have a drill, it makes the hole, then you put in the explosives and then you blast the explosives, right? So this is an alternative. The excavated material is also collected with mechanical arms from this continuous miner or guides and fed to the rear of the machine via conveyor. So unlike in a haul truck, you need like the haul truck and what's called the LHD, load haul dump, and or scoop, and you need the scoop to kind of take it away, essentially, like, so the scoop gets it away and then has to load it into the haul truck, and the haul truck takes it away. So you need kind of those two vehicles, whereas with a continuous miner, it kind of does that all in one. Now, these are actually already very commonly used in soft rock underground applications, but we've included it as an emerging tech for hard rock conditions. And so they're not used at all commercially available in hard rock yet. So when conditions allow, they can significantly reduce the need for, again, those drilling, blasting, mucking, and loading, and can be operated remotely or autonomously and integrated to conveyor systems. So again, remote and autonomous can bring large health and safety benefits. So some advantages, as I mentioned, they're all electric, so no tailpipe emissions, also, less noise and fumes. They are already, as I mentioned, suited to softer rock and ore types. And yes, I already mentioned the third point. Also, they're less labor intensive and less hazardous than drilling and blasting. So in a mining operation, the most hazardous, to my knowledge, is around the drilling and blasting, like for the worker to have like a cave in because the rock sort of sealing is not reinforced at where you're drilling and blasting. And so that's kind of when the person is putting in the explosives. That's one of the most hazardous times of the whole operation from a safety perspective, and can reduce or eliminate the need to evacuate the work area during the blasting process. And it can be combined with conveying systems to, reduce the need for conveying vehicles, like, as I mentioned, scoops and haul trucks. So one thing to note is that, in our experience, explosives are a minor greenhouse gas component, when we're looking at a greenhouse gas scope 1 inventory, but as mines decarbonize, reducing or eliminating explosive related emissions will become more important. So that's still a ways away, but we did see with one of our mining clients who got to 85% renewable electricity, and their explosives emissions were initially immaterial, meaning less than 5%, but as they got to 85% renewable electricity, the explosives did pop up to just around the 5% materiality threshold. So this was in a gold mining context, but we anticipate maybe it probably won't be for another sort of 10, 15 years, where, once you've got all renewable electricity and pretty much all electric vehicles, then that'll be really critical. Well, but you can start sooner. So I would say 5 to 10 years, it'll become more important. And then some considerations. So it does require high power electrical delivery at the working face. And so if you have like electrical grid capacity constraints and are not able to get that high power, then you probably cannot use this continuous miner. So I think working with your utility would be really important. And I know there are some utilities representatives on the call today. And it does require some more ventilation and dust control while cutting versus drill and blast. So not all the time, but just cutting. So again, making sure you have that power available, and you need to put that costing in your model too, just for the additional ventilation and dust would obviously consume additional electricity. It can be difficult to move or reverse the system other than in the working direction. So, repairs can be more challenging, and it can take up, if you're thinking, underground, that it's very, very tight space and so tight working areas. So yeah, it can be really difficult to fix anything that's broken, including, for example, cutting teeth or wheels that could require frequent replacement and high cost. So if you do have, cutting teeth that need replacement frequently, this can lead to significant downtime. So, again, working with the OEM to make sure that they have good answers to how this, there may be some data on, how often the teeth have to be replaced in a similar operation to yours. And roof control can be more challenging with the tight working conditions. So just to wrap up on the continuous miner in terms of adoption, as I mentioned, in soft rock, it's already very common. So in Canadian coal, gypsum, salt, and potash mines, but pretty much it's only in the development stage for hard rock continuous mining. So Sudbury's doing some work. I'm not sure if that's Vale or Glencore or both, perhaps, and then Australia also. And then they are most often for development tunnels, but can also be used for production. Okay, I'll pause here. Any questions, comments on the continuous miner?
I just
Not much. Yeah, go for it.
Oh, should I go ahead, Liz? Okay. No, just a couple of comments. So, as Emily mentioned, there's, I guess you could consider some other types of continuous miners that have been around for decades. In coal mining, you've got like a long wall cutter, which is basically goes back and forth along the seam. It's really kind of a form of a continuous miner, completely electric. We don't really see those types of operations that much in Ontario, but although you could use one in something like a gypsum mine as well, the sort of rotary type cutters, like we showed a couple of pictures, those are more for driving like ramps or drifts, where you're just cutting, you're running the roll horizontally up and down along the whether it's ore or rock. And the ones that are sort of more developmental for hard rock mining are more of a kind of a cone-shaped cutter wheel that is sort of boring into the face rather than kind of shaving it horizontally. And yeah, it looks like, something that is being tested, and it's, it's still kind of a learning curve, but really the interest in developing this technology is that it's completely electric, and if you can get it to the productivity levels needed, you could eliminate a lot of drilling and blasting, which obviously takes out a lot of other safety and logistical concerns. So it's kind of a hybrid of electrification and process improvement.
Perfect. Thanks, Bob. Great additions there. Thank you. Okay, so let's move on then to our fourth technology here, which is ventilation on demand. So for those who are not familiar what this means, it essentially is varying the amount of ventilation for underground. This is only for underground mines as required. So if you think for, if there are consultants here on like the building sector, this would be sort of analogous to building control ventilation, but like BCV, but this is for, again, underground mines. And so you can use sensors to monitor the air quality and control the ventilation, and coupled with like variable frequency drives to use it on a as needed basis. So ventilation is typically the largest electricity consumer in an underground mine. One thing to mention is that not only do you get major, and major because savings in electricity, because again, it's the largest electricity consumer, but also you can have typically in Ontario greenhouse gas and heating savings due to reduced mine air heating from natural gas or propane. So if your underground mine is not doing ventilation on demand, then I would very strongly suggest that you investigate this potential, because it's likely quite large. And there are varying levels of ventilation on demand, from sort of manual to automated, and you can have the automated ones. Sort of the best, highest level is with RFID tags, radio frequency, ID tags on personnel and equipment, and gas detection sensors that can be used to control the ventilation depending on the number of people and the type of equipment, because each vehicle has a designated amount of ventilation. So I've been in underground mines where they have on each level like the number of where all the people are, and then like the pieces of equipment. And when the equipment changes level, then they have to change the ventilation, and each piece of equipment has as I said, a different level of ventilation required. So It can also improve air and dust control during blast operations, allowing work to resume faster. So some of the advantages are up to 50% electrical savings, 45% in heating and related GHG savings. You can have a productivity improvement potentially because the fan control requires less time and labor versus adjusting mechanical doors and dampers, and gives a better control of dust after blasting, enhanced air quality control. And even though it's emerging in Ontario, it is a proven technology. So this is the one that, generally we would not consider ventilation on a sort of global context to be emerging. It's very much a proven commercially available technology, but also because of the different amount of levels, as I mentioned, kind of there's almost a pyramid, just like I learned early on in my career about the telecommunications period, and you have like the base layer and then all the applications on top. It's kind of a similar situation with ventilation on demand. And so this is, again, very proven, especially for the more basic levels, but still emerging in Ontario. So some considerations are the initial cost for the sensors and control and the software that would be typically, the sensors and sensors on, underground, but the software would be installed at your, on surface. In your control center, and then inspection costs, just making sure that everything's working correctly. VFDs on large fan motors do typically require engineering studies to avoid, possible noise, vibration issues, or harmonics versus a single speed operation. You want to have a bypass mode, so if the VFD fails, you can still run the fan on single speed, for example. And absolutely, you need to have a robust wireless infrastructure underground to enable the higher levels of VOD. So that's a must. So we're working with one mine right now who's hoping or planning to implement VOD, and they have in their sort of mine plan, they're getting the wireless infrastructure. I think it's almost sort of complete, but before, it's a sort of staged approach. And then in terms of adoption for VOD, so again, I would say there's some mines that are quite advanced already and some that have done almost nothing. So this is a pretty good technology that can be used, I would say, pretty much in every single underground mine. There are some of the technologies, like the next one we'll talk about, in pit crushing conveyance, that's only going to be applicable to a certain number, but this ventilation on demand to me makes a lot of sense in pretty much every single mine. So yeah, again, there's still many opportunities to implement or increase the sophistication of the implementation level. And the rapid adoption of the electric powered zero exhaust mining vehicles, so like the BEVs and remote operated vehicles, in Ontario has greatly changed the air quality and worker exposure in many mines, and then making even more opportunities to manage safely and cost of ventilation. So one thing I want to point out here, the last bullet is quite important. Ontario Regulation 854, which is for mines and mining plants, along with some related guidance in 2023, so pretty new, stipulates that the ventilation is based on diesel-powered equipment, and it no longer is talking about a generic horsepower. And then there's also sort of an ancillary general oxygen requirement to make sure you have enough, air, oxygen for the workers. But this is really critical because before this, you just had this horsepower. So if you had a certain amount of horsepower or kilowatts of battery electric equipment, you'd need to put just as much ventilation as diesel, which made absolutely no sense because when the people wrote the regulations, there was only diesel equipment available, and that's what they just assumed. So that regulation has been critical for the adoption of ventilation on demand. By the way, in BC, they also have great regulation that allows reduced ventilation for BEVs, and it is very important, though, to check the regulations in the jurisdiction of your mine if it is outside of Ontario or BC. Just for information, we did provide a training on general energy and emissions regulations information, not VOD specific, but if you just kind of want to know more in general about energy and greenhouse gas emissions in Ontario, we delivered this training, and it's again on that Save on Energy training and support website link, which we'll provide at the end of this. Okay, and that's it for VOD. Just pausing here again for any comments or questions.
Yeah, we do have a question in the chat, Emily. Are you able to share which mines have the RFID systems in place? John says he never got the pleasure to see them in practice, and most installation had more basic systems. There's also mention of one of the major barrier I understand to be with RFID is the wireless infrastructure and needing to work with the so-called quote unquote leaky feeder, which was not reliable enough for VOD. So he would be interested to know how the mine you mentioned is overcoming these challenges. So I don't know if that's a quick enough conversation for now, or if that's something to take offline for later. Up to you.
Yeah, I can't provide the exact mine without kind of getting permission. I don't want to sort of reveal, I mean, although this is positive, but just in general, yeah, I don't want to sort of reveal the exact mine. I do know about like the leaky feeders issue. They didn't, talk about it too much. This was part of a general sort of energy audit tour, so it wasn't specifically like a project on ventilation on demand. So I don't know all the ins and outs of their journey. So I don't think I can unfortunately comment too much on how they actually got it to work, other than it was working, I think, quite well. And yeah, they did have a robust wireless infrastructure. So I think just again working with your provider of that wireless infrastructure would be, I know like Cisco and I think Siemens and others provide those, and yeah, working with them. I don't know if Michael or Bob, you had anything to add to that?
No, I didn't have anything.
Yeah, in terms of mines that have done the sort of level 4 as it's known, one of the ones that sort of comes to mind is the Fosterville gold mine in Australia. We're using some tagging systems to adjust the ventilation on demand sort of automatically based on the vehicle location. So that would be one. And then I think there was another one in South Africa, I believe, at a Goldfields mine.
Thanks, Michael. Yeah, so those are ones, not the one I went to is like not public, but Michael must be referencing sort of publicly available where they talk about their VOD. So yeah, thank you, Michael. Appreciate that. Okay, great. So let's move on then to the fifth technology in pit crushing and conveyance, or I will be calling it by its acronym IPCC. So what this is, so first of all, it's originally for open pit, although in underground mines, you can locate a crusher underground and then use a conveyor system to hoist and then to move the crushed ore to surface. So, you can kind of have a effectively IPCC underground, but the name and sort of generally when we talk about it, we're more talking about open pit. So for the rest of this, I'll more be gearing for this technology to the open pit, but just know that it is kind of a possible analogous in underground as well. So what exactly is it? Well, instead of using haul trucks to move your ore and waste mixtures to a crusher many kilometers away from the ore body, and then you can instead you locate the crusher at the bottom typically of the open pit. And then the crushed ore is fed onto typically like many kilometers worth of a conveyor system that goes up and out of the pit and to the mill where it can be, ground, etc. And the crusher is sometimes permanent, but also some installations have some semi-mobile or fully mobile crushers. And so this can lead to significant reductions or even, eliminate the need for haul trucks and the associated cost and emissions. And so, yeah, you can have, also labor cost reductions because you don't have the drivers of the haul trucks. And yeah, there's some significant potential advantages. There's some disadvantages too, which we'll get into. So essentially, the advantages are it can reduce or eliminate the need again for these large haul trucks and also heavy road maintenance. The roads, if for those who are used to the mining industry, they have these vehicles called graders, which are constantly, like all the time, their whole job is just go around the mine and grade, meaning like flatten the roads. Because if you can imagine these, like, in the open pit, we're talking 200, 300, even 400 ton vehicles. They're definitely messing up the roads and creating sort of, all sorts of uneven surfaces in the haul roads. So, you know, that maintenance is kind of a constant all the time. And then fully electric, so therefore, again, the reduction in emissions and fuel costs. Operating costs can be 45 to 65% lower than the conventional truck and shovel. So that's some pretty attractive cost savings there. And conveyors can traverse rugged areas that are not suitable for haul roads. So I just wanted to elaborate on that. So the grade of a conveyor, so like the slope of the conveyor, can typically be higher than for haul trucks, like the grade of the road for the haul trucks. So this can be a big advantage in efficiency to move the material in as distance as possible without having to create a lot of switchbacks. Switchbacks are like the roads, you know, going back and forth up a mountain, or in this case, a pit gradually. So some of the considerations, though, are that, you know, there are higher initial costs to getting that system in place compared to truck hauling, and some significant custom engineering design. So there is a significant engineering component. Selection of suitable conveying components is critical. And we have heard, you know, from miners of situations where there's failures or accidents involving the conveyors, and it can shut down operations for extended periods. So this is a huge problem. Like if you think of if you have one haul truck break down, then you just have other haul trucks that can, you know, haul your ore, and you can have that get to the mill and make your money, essentially, which is what the miners are, of course, trying to do. If you have just one in-pit crushing and conveying system, which is what you generally do, you have like one main conveyor that's conveying all the ore, and then it breaks. That is a major risk in terms of, you know, you could, as I say, shut down entire operations and not be able to get sufficient ore to the mill for the grinding stage. So there is some significant risk that needs to be dealt with there. And then the physical constraints of many existing mining operations may not support the IPCC. So you do want to decide at the beginning of the mine design for IPCC. Otherwise, it's not cost effective if you've, you know, already purchased all of the trucks, for example. And lastly here on IPCC is the adoption. So it's not very common in Canada, but it is something, you know, to consider for future mines, as there is a large potential savings. So we have some examples from a large iron mine in Brazil, and they replaced 100 trucks. So they had a mobile crushing system and 37 kilometers of conveyor belts, reducing diesel consumption by 70%. So again, if you can get it to work, the savings are very, very large, but you just have to make sure there are some risks, as I mentioned, as well. And then we've given some other example of installations across the world. And yeah, I'll pause there for any other questions or comments on in-pit crushing and conveying.
So far, no questions. I can give it a couple of minutes if Bob has something to add.
Yeah, I just had a couple of comments. So this is one of those technologies that, you know, at the start, it's like, well, it's a conveyor belt. It doesn't look like anything, you know, too emerging. But over the years, it's one of those technologies where it versus, say, haul trucks, it really depends on a lot of different factors. Certainly the availability of very high quality, like conveyor systems, especially on the maintenance side. There's been systems that have been installed and then removed just because they just had so many years of problems with bearing maintenance and belt maintenance, and they put in systems taken out. Like I know there was some examples in the oil sands mining where that's happened. Even some of these large mines, as the mine gets deeper, or maybe they start developing another pit further out, maybe the belt system makes less sense. It really, but I guess what is driving this sort of resurgence of it now again is the electrification aspect that makes it that much more attractive, just in terms of, you know, reducing all that diesel-based haulage. There's, I guess, even and one just my colleague Michael noted, just just recently we noticed that there is another system we didn't talk about. There is one that's in British Columbia, but it was installed in the 1980s originally. It's still in use, but it's basically a supplementary system. Again, the mine has grown quite a bit since then, and they still use a system, but most of the ore is now actually transported by truck. So it really depends on the mine site, and especially it needs to be a mine with a long lifespan, and then take it into account, basically if it's the maintenance that's going to kill you on these systems versus what the potential savings are for on the greenhouse gas side and electrification.
Thanks very much, Bob. Great additional points there. So thank you, especially the long life of mine, so that you need to make sure that that additional infrastructure cost can be kind of, I guess, managed and over the life. So sounds good. Thank you. Okay, so let's go into the last technology here then. We're going to look at two different alternative milling technologies. So just for those who are newer to mining, the ore that comes from the mines goes to the mill for the mineral processing. And in the mill, the mill is typically the largest electricity consumer of the site. And grinding of the ore is typically the most energy intensive process in the mill. And you have these, the mill is the name for the overall building, but there's also specific pieces of equipment called mills. So what's called semi-autonomous grinding or SAG mills, ball mills, and rod mills. And they're all kind of the same thing, basically a cylinder that turns, and they have either steel balls or steel rods, or it can be some other materials too, but steel is the most common. And basically they turn these mills, these big cylinders that are huge, and the balls or the rods hit the ore and grind them up into smaller pieces. So those specific mills are usually the largest energy using equipment in the mill, typically in the megawatts or even the tens of megawatts. So I was at a mill in BC a few months ago, and they have, I think, possibly the largest or second largest SAG mills in North America. I think they were each 25 megawatts each or something. So yeah, 50 megawatts just from two SAG mills. So very large. Bob, did you want to say something or? No? Okay. And then, so yeah, in terms of, that's the standard traditional equipment. Then if we look at some energy saving alternatives, we're going to look at two of them. One is called HPGR. It's high pressure grinding rolls. And the high pressure grinding rolls, essentially you have like two large rollers. So again, think like long cylinders with the same dimensions, and they are rotated against each other at the same speed to crush and compact the material. So these rollers are basically, crushing and compacting the material versus having these balls or rods like hit the ore. And so this is more efficient. And another efficient technology, or well, more efficient, they're still, grinding is super, super inefficient. But these are more efficient. So Vertimills, as they're known, are vertical mills. As the name suggests, they're installed vertically. And you have a large screw that is, mounted vertically to lift and grind the material. Now these are usually for smaller particle sizes, so they can sometimes, you often have like multiple stages of grinding, so you can have what's called primary and secondary and tertiary grinding, and so Vertimills can sometimes be used for the secondary or the tertiary grinding. So let's look at some of the advantages and considerations. So HPGR can completely replace the conventional SAG, rod, or ball mills with about a 35% reduction in electricity consumption, and Vertimills can provide up to 40%. But again, Vertimills, you do have to be careful. They are usually for the smaller sizes, and you do need to work with an engineering firm who specializes or knows this, because there's a lot of pretty complex information that needs to be taken into account. And both technologies provide, improvements in process control, maintenance, and cost. So just you do need to make sure that the grind size that you are looking for can be attained with the HPGR, and specifically, in particular, the Vertimill. You need to look at the cost of replacing existing systems if they're still in good condition. So one thing I haven't talked about in all of these technologies is related to asset management, and it's really important from that your energy manager is working with whoever's in charge of asset replacement and asset management, because you want to, as you're trying to implement these energy efficient technologies, work where hopefully you're not replacing equipment that's in the middle of its life, but you can kind of wait till the end of the life to improve the economics and not miss opportunities to have all those studies complete and ready to go, and to be like, okay, we're getting to the end of life, okay, but we've done all the studies and we know we want this sort of newer technology. And then significantly increased mechanical complexity and therefore potential for failure if not well maintained. So you do need to consider that. In terms of adoption, these technologies are becoming well adopted in Ontario and other areas of Canada. For example, a Canadian iron ore producer awarded an order for 2 vertical mills to be delivered this year, and an Ontario gold mine uses HPGR with a ball mill followed by 2 vertimills. So that just kind of shows that, again, it's not necessarily one or the other. You can kind of combine these together. And just before we wrap up and I turn it back to Maëlys, one thing we have not discussed is, how to pay for all of these emerging technologies, and I did want to bring that up. So for Ontario operations that are participating in Ontario's industrial carbon pricing system, aka the Emissions Performance Standard Program, the proceeds from that program, and it has its own name, the Emissions Performance Program, or EPP, you can use the amount that you paid in your industrial carbon pricing for decarbonization projects, such as the implementation of these technologies. So you could use, again, that Emissions Performance Program, which notionally you get approximately the same amount as you paid in. So say you paid in, $500,000 for the Emissions Performance Standard Program, then you could use that $500,000. Well, you have to, if you want to use it, the only thing you can use it for is for decarbonization. So you could, implement one of these technologies with that money. And if you don't know very much about, the industrial carbon pricing system in Ontario, we have already provided training earlier this fall. And again, we'll provide that link at the end to the Save on Energy training and support. And also, for helping to pay for these emerging technologies, there are many incentives available. And again, we also did a previous training on incentives for energy efficiency and greenhouse gas reduction projects to Ontario industry. So not just mining, but all of Ontario industry in Ontario, and also some federal programs. So I know there are some people who are outside of Ontario here. We didn't do other provinces, but we did do federal. So again, you can check out that website at the ISO. And finally, 2 last items. We have developed a fact sheet for this subject, emerging technology in mining. And Maëlys, I think, is going to be able to provide that link in the chat to that fact sheet. And there is also a best practice guide per industrial sector that is being developed currently. And there is a section on best practices in mining from an energy efficiency perspective. So this is different than the emerging tech, because the best practice guide is just sort of standard best practices in energy efficiency of commercially available technology versus sort of the emerging technology, which is, more forward looking. And that best practice guide will be available in Q1 2025. And there's about, I think, 10 different sectors there, from, automotive and chemicals to mining and steel and other types of manufacturing. So keep that in mind. And with that, I guess I'll pause for any questions on the alternative milling before I hand it over to you, Maëlys, just to wrap up.
Yes, we do have a question in the chat. So for the Vertimills, is there a risk of interactive effects where you need to add more energy to crushing that occurs prior to the Vertimill in order to have a fine enough grind to feed the mill?
Yeah, so that's a good question. I mean, it could happen. That could be an interactive effect that would occur. It is really a case by case basis, I would say. So if you're getting the same size into the Vertimill as in sort of the base case, then the Vertimill should be more efficient, and I would say you do not have to worry about that. But if now you're suddenly feeding in a different grind size to the Vertimill, you're not really doing apples to apples comparison, so I'm not sure if that's the best. But in that case, yeah, there could be some interactive effects. I'm not sure if Bob or Michael, you wanted to add anything to that?
Yeah, just I know that's a field for experts, in milling, really to kind of make those assessments. And like you said, it's a case by case basis. I think you definitely want to make sure you've got the people who know what to look for, checking those things out before you spend any money.
Yeah, very as I was mentioning, you need like specialists in engineering, design of these mineral processing. Yeah. Thank you. Okay, I think I will turn it over to you, Maëlys, to wrap up then.
Sounds good. Thanks, Emily, Bob, and Michael for a very informative session. So if you have any questions following this session, you can use our post-webinar support intake form, and I will put the link very shortly in the chat. Basically, this form allows you to tell us, hey, I attended this info session, I have a follow-up question, and we'll send it to Emily and her team. If you want to be aware of upcoming events and initiatives, you can sign up for our monthly bulletin, which recaps all of the training updates, so new fact sheets that become available, webinars that will happen in the coming month, or you can go straight to our live training calendar. And again, to find recordings of previous sessions, you can go to the training and support webpage. There's also a wealth of information such as fact sheets, guides, and other static resources that you can find in there. So I will put all of this in the chat right now. It is going to look very big because I copied it from the slide, but this way you have all the links that are on this slide accessible. I think that is it for today. If you can go to the next slide, Emily. Well, we have basically the sign up. Yeah, if you want to sign up for Save on Energy's bulletin or email us if you have any further questions, feel free. I can give everyone 2 minutes to see if there's any final questions in the chat, but otherwise I think this will conclude our session for today.
I just want to say
thumbs up.
Yeah, thank you so much, Maëlys, and to my team, Bob, Michael, and others, and to everybody who attended and all the great questions. Hopefully you learned some things today, and yeah, thank you very much.
Thank you.
Thanks, everyone. We'll wrap it up here. Have a good day.